Okay, so thanks for coming. We have about 40 people online and another 20 or so people in the class. Thanks for coming and thanks for waiting again. Today we are going to start in deeper topics. We will move more slowly and try to understand civilizations and science from the beginning. So if you have anything that's not understood, please let me know. Again, these topics are very difficult compared to computer science and engineering because so much reading is required. You should try to understand the fundamentals and general ideas on those topics. If you are interested, you can read a lot of things on that, but full comprehension is usually very difficult. In the Middle East, everything started in Middle East, today's civilizations. In those years, magic and science has no difference. So people who did clever things were taught as magicians and sometimes religious people, like priests, etc., shamans. When person becomes ill, doctors prescribed magical formulas to be recited, including some talkative things, to treat the sickness. Earliest medical prescriptions appear in Sumerian tablets in 2000 BC, so 4,000 years ago, medical prescriptions for certain diseases. Again, Mesopotamia is due to the property of the land and irrigation, considered as a beginning of the civilization in most books. First, the scientist-like person was the healer guy, Asipo. That was taken from the book. That healer person, that kind of job was passed down from father to son. So if your father is scientist, you will be scientist. If your father is medical person, doctor, not doctor, but medical person, healer, you will be healer. It is because the abilities are transferred from generation to generation by learning at home. So most, unless there is an exception, most jobs were transferred from father to son, including scientists. The less frequent recourse was another kind of healer, Asu, that corresponds more closely to a modern physician that treated physical symptoms using primarily folk remedies comprised of various herbs, animal products, minerals, oils, etc. So they want people to drink something, drink nane, for example, to treat sicknesses. That was early cultural example. Since they are very into tablet writing, a lot of things were done related to clays, kill tablets, sand, metals, bitumen, the early form of petroleum, stones, and other natural materials. So material handling, material processing was available. Therefore, use of those knowledge in pottery, glass, efendim, efendim. Annen alıyor. Hadi bay. Bay bay. So it was possible to do some technology using materials, material handling, chemistry, etc., including medical treatments. Yeah. They didn't have much interest about natural world. They didn't have much interest about understanding natural world. They were interested in how God has created the universe. They had certain stories about how world is formed, etc. So those stories were important part of their life. Later, it became their religion. One example, which was very interesting, contains mathematics. That clay tablet includes the table for a square plus b square is equal to c square table. They pre-calculated the squares and then stored the results. That was the question in the previous hour for the multiplication. You asked for that. So Sumerians, Babylonian tablet contained that kind of information. They pre-calculated the numbers and stored on the tablet. So when they need it, they just look at it. There were a tablet like that. It was dated about 1800 BC. Also, they were interested in astronomy. They recorded the motions of the stars, planets, and the moon, etc. The reason that we use 360 days and 360 degrees in mathematics dates back to Babylonians. A circle is made up of 360 degrees, etc. Because they count number of days in a year, etc. So they wrote those information on clay tablets again. So that's the origin of the today's calendar system, solar year and lunar month. Babylonian Mesopotamian astronomy was very interesting. That was, as I said, that was the root of today's astronomy. And about the stars, planets, and the moon, there are still thousands of clay tablets available today. Yeah. First mathematical attempt to giving explaining astronomical properties of stars and moon and sun. Later in Greece, India, and Islamic world, all Babylonian science is inherited. So it depended on Babylonian science first. Arabs also took a lot of things from them. Greeks took a lot of things from them. Also Indians took a lot of things from Babylonians and Sumerians. Next is the Egypt. Egypt was interesting. Again, just like Mesopotamia, a very good for irrigation and very nice place to live. Therefore, they developed skills for farming, and farming resulted in being ability to stay in villages for feeding them. Therefore, society formed and population growth is more sustainable because they were not hunting, they were farming. When you do farming, you can store food for next year, etc. So society is more stable. What they did initially was right triangles. They make pyramids, etc. So a lot of things were dependent on the Nile, the tides of the Nile, yearly tides. One sıkmaya başladı. Şöyle yapayım. Tides of the Nile was very significant in their life. One of the reasons they invented certain mathematical issues were farms were lost during flood. When the flood goes away, they want to redistribute farms to farmers. So each farmer has a record of the land, what they have. So a measurement guy comes and from here to here, this is yours. From here to here, this is yours, etc. every year after the flood. Therefore, they developed geometrical skills in addition to doing those pyramids. They also invented post and lintel structure. It may look very simple, but putting another stone on top of two other vertical stones is first implemented by Egyptians. Three, four, five right triangle structures. They also tried to mix different things to obtain various substances called as alchemy, early chemistry, and medicine. First medical documents also found in Egyptian documents. Egyptians had one advantage over others. Egyptians found paper at the same time with people in Pergamon in Turkey. One was made from papyrus, other one was made from parchment. Instead of writing clay tablets, they started writing on paper-like substances, which can be stored for thousands of years. Today we have those papyrus things. For one example here is it explains a medical, it contains a medical text about surgical procedure on a patient for a certain disease. Probably most patients were dying. If they live by chance, but still they wanted to do something. That's what I was saying here. Many historians believe that ancient Egyptian pharmacology, medicine, was largely ineffective. So, however, they examine, they diagnose, they treat, and they follow what happened after that, which is prognosis in today's science. They did all of that. So we can compare it with today's empirical science. They look at the disease, they think about solutions, they implement the solutions, and they write down the results. They follow the results. That's a scientific method. There was a papyrus 1500 BC dated, contains evidence of traditional empirical approaches. So test, see if it works. If it doesn't work, change, etc. Don't just assume that it's going to work. Then Babylonians, Egyptians, then Greeks. So in most cases, in most documents, Greece is considered as a origin of science, like Pythagoras, etc. But as we, okay, it failed. That was interesting. It was the window, arkadaşlar. Not the bump. Thanks. So Greeks are interesting. Most Greek people gathered their knowledge, or starting from Egypt and Mesopotamia, then improved. Many mathematicians came out. They taught about the purpose of the universe. They did a lot of philosophy, purpose of the universe, understanding the nature, etc. Some nations did go more into engineering. Egyptians, for example, more. They have created solutions for existing problems. But Greeks mostly think they try to understand causes, and they try to understand the nature. That was the fashion, probably, in the Greek land, in the Turkish part or in the Greek part today. Therefore, the term natural philosophy came out. Natural philosophy, doğal philosophy. That contains inquiries of the working of the universe. That includes human body. but for quite amount of time, human body was sacred, so it cannot be studied, except some outgoing scientists. First century mosaic from Pompeii, Plato's Academy. So they discuss issues. They discuss natural philosophy in Pompeii. Pompeii in Italy, you know, the volcano destroyed the city in when 70 BC, 70 AD, I think. So that mosaic is from that time. In the old days, in the Greek time, scientists are philosophers. So philosophy and science were mixed. Also, they were doctors, they were religious people, they were everything, because there were not many books and schools in the world. So once you go to the school, once you go to an academy of Plato, for example, you learn almost everything that are accumulated so far. You are engineer, you are doctor, you are philosopher, you are thinker, everybody. Some of them are followers of religious tradition. Therefore, a lot of scientists are also religious priests in those years. The famous names were Aristo, Archimedes, Hippocrates, Galen, Ptolemy, Euclid. So they are all Greek Anatolian people. Their works were written. They wrote certain books. The famous book is Euclid's Elements. That is that's a mathematical book which was taught for the longest time in history. If I'm correct, it was taught in schools for 1,600 years. Same book. So Euclid's Elements, this book was obligatory in classical mathematics classes in certain universities in Europe until I think 1950s or 1960s in mathematics departments. So it's like studying classical mathematics, etc. Not to teach regular mathematics, but as a different course, it was studied. But in the 17th century, 18th century, including time that are closer to Christ, because it's 1600 years. That book was the main mathematics book. You can purchase the book. Ya ben Euclid's Elements. Let's see. The book was written in 325 before Christ, and 13 volumes. 13 volumes book. handwritten book. And it was translated to many different languages, including Turkish. It includes logic, number theory, geometry. Okay. It was printed many times in Renaissance ages. Before that, it was translated to different languages, right? And this is very important. Euclid Elements was written in 325 before Christ. So it was translated to Latin in 1505. How many years later? 1800 years later, 1800 years later. And I think I was wrong by giving you 1600. It was more. So it was translated to Latin, Italian in 1543. It was translated to German, multiple translations to German. Okay. It was translated to Spanish. It was translated to Arabic. And it was translated from Arabic translation to some other language, to French, to Dutch, Chinese in 1607. So it was translated to Chinese, and Chinese scientists studied Euclid's Elements. Then Dutch, French, German again, English, French, Italian. So they improved the translation, of course. Some other person translates. Then 1700, Danish, Italian, Jewish, 1780. Jewish scientists translated Euclid Elements to Jewish. So they studied it. Then they translated to Russian from Greek version because they are Orthodox. French, again, Italian, modern Greek, Swedish, 1850, still 2000 years almost. Hungarian, Japanese, Russian, Czech language, Portuguese, and in 2019, fortunately, it was translated to Turkish. So, guess how important it is in our life. So almost 2,300 years later, it was translated to Turkish. I was going to put that in slides. So 200, something like this. Euclid's Elements. In the old days, for example, first calendar in Greece mentioned about 700 BC. That was way later than Babylonians. So the origin was Babylonians, but Greeks accumulated those kind of things around. The first mention is about 700 BC. Works and days incorporated a calendar in which the farmer was to regulate seasonal activities. So farming is very related with the calendar operations. When to irrigate, when to stop, when to get the crops, etc. the phases of the moon, etc. Around 450 BC, seasonal appearances and disappearances of the stars like Jupiter and Saturn, the most visible ones, or the Venus. They were discussed in certain texts. They wrote texts. They used to regulate the civil calendars of Greek city-states based on astronomical observations. So they defined holidays, for example, holiday notion based on the calendar and lunar observations. 450 BC. In terms of medical progress, the famous Hippocrates. Hippocrates is a person from Kos Island. Kos is actually in Turkish İstanköy, across Bodrum. He lived around 460 BC, 370 BC. So it's same, just before Euclid's time. They talked about healing process and classification and writing down what to heal, what heals who, etc. So writing down was important, and Hippocrates was one of the first of them. Kos, Hippocrates of Kos, they say. There are other Hippocrates because on the sacred disease that deals with the nature of epilepsy. He studied epilepsy. Sarah. Author attacks his rivals, temple healers, for their ignorance and for their love of gain. Temple healers, they read certain text in front of the person and expect them to heal. But Hippocrates says they were ignorant. The problem has a natural cause, so that natural cause must be eliminated, then the person can be healed, rather than reading the text on Tarihi. So he was one of the first people who was in conflict with temple healers in this sense. So he insisted that epilepsy has a natural cause. He didn't find the solution, but he insisted that it was not because of the sin, because temple healers were believing that you were acting differently because the certain things happening to you in terms of famous. If you look up books, probably more than 3 or 4 books came up on sale. So in order to understand Socrates, you have to read a lot. I didn't. I am trying to read about that from several sources. For Socrates, their name was pre-Socratic time. How did the order cosmos in which we live come to be. So the son has another child, and he born except Zeus has two more than other Greek gods. But the earliest philosophers also tried to give materialistic answers to the same question, in addition to myths. So they didn't explain things with gods, they explained things with a material source of things. So they thought about fire, they thought about earth, stones, etc. So they tried to explain how the earth is formed, how the earth is created with materialist approaches. Again, in Anatolia, in Millet, Thales. Thales is this guy. It said all things are related to water. So it's a kind of true, because hydrogen is the smallest atom. So if you think that hydrogen contains the basic atom and the center, so everything is made up of water and so related to it. One idea of the Thales. These guys are also mathematicians. They think about the reason of the universe, etc. They also study mathematics, geometry, etc. There is a Thales theorem, for example. Anaximander is interesting. Also, he studied cause of the universe. Things could not come from a specific substance like water, like Thales said, but rather from something he called the boundless, something intangible. So, kind of atom, but not quite. So they can do experiments. They are trying to figure out by thinking. It returned to a concrete material substance, air, that could be altered by refraction and condensation. So from the vacuum, by squeezing the vacuum, you can generate materials. If you squeeze a lot, you get stone. If you squeeze a little bit, you get wood, for example. Less squeeze, more squeeze. He also demonstrated that air was a substance and simple experiment by pulling with the pipe, breath, and showed that it could be altered by refraction and condensation. So air, matter can replace each other. At least he studied, and he tried to explain how matter is formed. Again, in Anatolia, Again in Anatolia, Heraclitus of Ephesus. Change is fundamental rather than substance. So it's not the substance we should concentrate. He said change is more important. So the change is caused by fire. So fire changes things from one form to another, from wood to ash, from ash to stone, etc. Also metals. So Heraclitus said it is the change that creates different forms of objects, different forms of substances. Another guy, Akra Empedokle, it is important. He coined the term earth, toprak, earth for toprak, earth, water, air, and fire, which will be the main understanding of the universe for a long period. And they produce everything by mixing and separating in certain quantities. Some fire and some earth creates some other thing. Some less fire and more earth creates a different thing. Some water is added and another object is formed. So under the influence of two opposing forces, that called love and strife, pulling and pushing. So just like atomic forces. He was influenced by Pythagoras and Pythagoras people. He was influenced by Pythagoras. He challenged the practice of animal sacrifice and killing animals for food. So he was kind of vegetarian. Those years. Also, he developed distinctive doctrine of reincarnation religiously, and probably it is the animal sacrifice prohibition is related with the reincarnation, because you may reborn again as an animal for that theory. So they are going slowly towards atoms. Two philosophers, up to that time, the matter was continuous. But two Greek philosophers, it is later forgotten. How do we read it? Leucippus and Democritus came up the idea that atoms, actually they were the owner of the word, atoms which were small indivisible particles of matter, and the void, empty, which was the empty space which matter was located. So small indivisible structures were atoms. Again, they made it by observation and thinking. No experiment, no nuclear experiments, of course. Pythagoreans was materialists, so they try to explain they try to explain the cause of the earth, the cause of the materials. Classical explanations were not sufficient for them. So what they did is try to focus on how random assemblage of water produce an ordered universe without existence of some ordering principle. So that is a very famous question, actually, even today, how a random operation can bring up an ordered universe like this. Without a principle, how can it be? Before it is 2,600 years before now. So they tried to make a model, and for the model, they said matter was made up of ordered arrangements of atoms. arranged according to geometrical principles into triangles, squares, rectangles, and so on. So they believed that geometry is, well, that's correct. I think that's correct interpretation. Geometry is God. That's what they thought. So everything is based on principle. Geometry determines. Geometry is the determination of everything. Mathematics is determination of everything. So if there is a mathematics, there is an intelligence. Since mathematics is already there, for example, a right triangle, 3, 4, 5, right? Right triangle is right triangle. So even if you don't draw the right triangle is there. The information is there. So what they say is the order in the universe is there. Even if you don't discover it, it is still ordered because mathematics is still present, even if you don't know it. It is kind of consistent in itself, but with today's knowledge, I think it is not sufficient. So Plato, in Turkish Eflatun, and Aristo, Plato found the ordering principle of universe in mathematics, specifically in geometry. Like geometry is itself is the order and the cause of the order. Later account has it that Plato had inscribed at the entrance of his school in the book. We have seen the mosaic in Pompeii city. Let no man ignorant of geometry enter. So if you ignore geometry, don't enter from this door. He wrote at the entrance of the academy. Because there were no regular schools, there were academies by certain philosophers like Tekke. So their rules were determined by themselves, not by the government. Plato said, story is a myth, but it has a grain of truth, some truth. For in his writings, Plato, he said, tells us the importance of geometry. He says geometry, geometry, geometry, geometry. So order, actually. He is known for more for philosophical basis rather than scientific method, but actually in those years they were philosophers and scientists together. So they are mathematicians and thinkers. He said, I'm going to stop quickly. He said, all things in the material world are imperfect reflections of eternal unchanging ideas, just as all mathematical diagrams are reflections of eternal unchanging mathematical truths. So I just said it in my previous sentences. Mathematics is there. Mathematics is the universe. What we see is, this is very hard to explain. What we see is the reflection of the mathematics as a matter. That's what they said. Since he believed that material things had an inferior kind of reality, materials are inferior. So this is inferior than the mathematics itself. Mathematics itself has become visible in the wood or in the matter. So we don't achieve demonstrative knowledge by looking at the material world. So without studying abstract mathematics, he said we cannot understand things by examining and studying the elements. We have to study mathematics to understand actual objects. And I'd like to point out that some of the ideas of those people were wrong. Some of them are correct. So when I am explaining these, when I am trying to give these ideas to you, please don't think that I am against or with those ideas, because some of them are incorrect. We are just studying it for understanding how people achieved up to this time. Truth is to be found through rational demonstrations, experiments, similar to demonstrations of geometry. For example, this is cutting, the line is cutting the circle, so you can prove it, you can show it, you can measure it, and that can be realized in real life, like an apple cutting with a knife. So in that case, part of the apple is gone, so it is realized. So it is analogous to demonstrations of the geometry. Using this concept, he said astronomy should be studied in terms of geometrical models, and proposed that elements were particles constructed on geometrical basis. So all elements in space are geometrical counterparts. Plato said that. Let's few more slides. They disagreed with his teacher. Aristotle disagreed with teacher. He agreed that truth must be eternal and unchanging. Aristotle said that. Plato was thinking differently. Aristotle said truth must be eternal, unchanged, and truth, we know truth through external world, which we perceive with our senses. So we have to see, we have to hear it to understand the truth. He said direct observable things are real. If we cannot observe it, it is a myth. It's not true. So we have to observe. But Plato said with mathematics we can do induction. So for example, derivative. There is a realistic part, but you can also hypothetically study the problem of derivatives. So for living things, it was real only if things only exist if they are visible. Aristo said. Derler ya Aristo mantığı, düz mantık diye. If I can see it, it exists. If I cannot see it, it doesn't exist. But Plato said in mathematics, you have to study mathematics, and mathematics reveals itself with the nature. So there must be something that may not be revealed, but it is still there. So it's more, Plato is more abstract compared to Aristotle. He made observations, because he said so. He observed observations. Animals at the Sea of Lesbos, that's the island. He did taxonomy and categorizations. Go ahead.
So many nations wrote Greece, and there may be a change in these archive books.
There are original writings. Some of them are original writings. Some of them are stone writings. So, what I believe it today, people who study them are also scientific people. And those scientific people, I don't think they will act like politicians. So if they say it is less, if they believe that it is less probable, they don't say so. Why shouldn't? He made observations, and probably there are papyrus of those observations somewhere found, or some writings. Some of them are not found. Most of them are not found. They interpolate what they found. They make assumptions based on the findings. He made observations about the large-scale workings of the universe, which led to his development and comprehensive theory of physics. Interestingly, for those years, there was a scientific instrument found in the Greek Sea some years ago, like 10 or 15 years ago, I think. It was a star and measuring device. I'm going to send the video to you tonight. It was too complicated. It was complicated in the sense that it can be implemented in after Renaissance, like 1600s. So that kind of clock-like device, but it was before Christ, based on the measurements. That was interesting. So there maybe a lot of things are lost in those years. The classical elements theory, which was earth, fire, air, is improved with the addition of ether. Ether was also the first Greek god who was there before anything. Ether. So, meaning empty. And the notion of ether was assumed correct until 15th century and 16th century. So then they differentiate the difference between vacuum. Until vacuum is found, people didn't believe that there was something like vacuum. There was a material that fills those gaps, and the name of the material was ether. Space, for example, was filled with ether in those years until 16th century. Fire and air repels each other, others attract each other. So he tried to develop certain rules based on observation. Obviously, these are not correct, but they are trying to explain the nature. And since bodies in space move around circles, the Jupiter and Saturn, etc., and the Sun and Moon rotates in circles, he concluded that they must be made from the fifth element, which they called ether at that time. This is the last slide for today. I know it is not easy. It's not easy for me either, because it's all memorization. I mean, it's not like teaching a programming language. But it is interesting. I mean, I like it. The Hellenistic period is very long. It goes back until Romans. So it expanded to Egypt, Middle East, Persia, and up to India, and all the Hellenistic period combined information that was created in those areas before Greeks. So since Hellenes expanded, they gathered all the information created, especially in Egypt and Middle East. Alexandria in Egypt was center, and Antioch in Syria. Antioch is a city in old Syria. There were cities of science, cities of libraries, etc. Hellenistic science and Greek science were different, what they say. Hellenistic science benefited from Greek ideas. And Hellenistic science is more like United States versus British. United States is kind of British, but United States is more wider and touches more different parts of the world. Second, it was supported by royal patrons in the kingdoms founded by Alexander's successors. So Hellenistic science was founded by kings. In the Greek time, there were people, free people, getting together and opening an academy, and philosophers start thinking and writing things. So it was like free universities in certain regions and people. But in Hellenistic period, kings were also interested. Especially in the Hellenistic time, Alexandria in Egypt became major center of scientific research in 3rd century BC. So 3rd century BC is 300 to 200, right? Yeah, 300 to 200. So just before Pythagoras and etc., Egypt was gaining a lot of popularity. Just before, not just 200 years, 300 years, before Christians, Jesus was born in Israel. I think that's this mechanism. Yeah, I included this Antikythera mechanism, 150 BC. 37-gear mechanical computer, which computed the motions of the sun, moon, including lunar and solar eclipses at that time. Sorry. Antikythera mechanism. You may have seen that, so I am going to show you the video of this. Antikythera. Antikythera diye yazalım bakalım. So this BCE'de gemi batmış. makine. This mechanism el yazması. Something like this. We don't know if it is made by Greeks or Egyptians or somebody else. Çin de gösterecek şimdi. Falan filan. Falan filan. This thing. So they were able to make gears. They were able to connect the information that they gathered from observing sun and solar moon operations, movements, to the gears. They apply the same information to gears so that they can simulate time for 19 years further from the existing time, so that they can predict from 3 years from now where will be the moon and the space. So they were able to tell that. Almost 2,000 years ago. I think this is good for today. You are all tired as me. If you have any questions or comments, please let me know.